Okay, so my problem was probably treating foreground object. The question was to look at the flat photograph and to allow you to tell which objects were closer and which were farther from the camera when the shot was taken. And I needed to design a great photograph that violates the intuitive judgment of relative distances. I decided to experiment on objects of a certain size that would be proportional, and I examined the distance between the camera and the object in the first plan would be substantial. So with just a little bit of theory, the perceived size of an object depends on the visual length studied by the object, which depends on the visual on the size of an object and the distance from the observer, and it depends on the perspective. As we see in this picture, the aim is distorted room. On the picture on the left, the person seems smaller, and on the right, the person seems bigger, because the angle of the room was crooked, and we could see that it made a difference on the size of the person. So a little bit about lenses. There are two types of lenses, concave and convex. Convex lenses are thicker at the middle, and rays of light that pass through the lens are brought closer together. They converge, and when parallel rays of light pass through a convex lens, their refractive rays converge at one point called the principal focus, and the distance between the principal focus and the center of the lens is called the focal length. And these lenses are used in cameras. Concave lenses are thinner at the middle, and they are diverging when the parallel rays of light pass through a concave lens. The refractive rays diverge, so they appear to come from one point called the principal focus, and the distance between the principal focus and the center of the lens is called the focal length. The image formed is both virtual and smaller than the real object. My hypothesis was that I could manipulate the human perception of size by moving bigger objects further away from the camera and moving smaller objects closer. I could make a ratio in which we can observe and predict at what distance we need to move away the bigger objects so they seem smaller, and I would try to reenact the aim to distort the room by instead of using the room, I would just use the paper as the background, but I would modify it to serve as the room. Methods of measurements, I created 6 Grgur cubes from 1 to 6 centimeters tall. I put them under different distances from the camera to test if the basic distance of the smaller object from the camera had effect on the distance that we need to put the bigger object for it to seem the same as the smaller one. And I put the cubes in certain regions and kept moving away the bigger object by 5 centimeters until it seemed the same size as the smaller one. So the first ratio that I will be testing is 4 to 5, when we have a 4 centimeters tall cube and 5 centimeters tall cube. All that was to move the 5 centimeters to 5 centimeters back from the 4 centimeter cube, and they seem the same size. So basic distance from the camera is 30 centimeters. At this time, the basic distance we needed to move the 5 centimeter cube 10 centimeters away from the 4 centimeter cube, which is larger than the last one, and at basic distance of 40 centimeters, we need to move the 5 centimeter cube away 15 centimeters away from the basic cube. In ratio 1 and 2, the basic distance of 20 centimeters on the camera, we needed to move the bigger cube 25 centimeters away from the smaller cube. At basic distance of 30 centimeters from the camera, we need to move the bigger cube 35 centimeters away from the smaller cube, and in ratio of 40 centimeters from the camera, we needed to move the bigger cube 45 centimeters away from the smaller cube. And I also tested putting the closer smaller cube on the top of something, meaning the top of the further away one would make it more realistic, and it did. They look approximately the same size. In ratio of 2 towards 4, so I made this ratio to see if it was any different from 1 towards 2, and it wasn't exactly the same. When the basic is 20 centimeters, I need to move the bigger cube 30 centimeters instead of 25 in the last ratio, and when the basic distance is 40 centimeters, I need to move the bigger cube 50 centimeters instead of 45 from the smaller cube. And ratio 3 towards 6, I made this one to confirm, or this confirm that the ratios which are proportional are the same in these pictures, and they are not. When the basic distance is 20 instead of the last 30 to 25 centimeters. When basic distance is 30 centimeters, I need to move the bigger one 35 centimeters away from the cube. And when the basic distance is 40 centimeters, I need to move the 6 centimeters cube 50 centimeters away from the smaller one. This is the reenactment of the ancient sorting room. The cube on the right actually looks a little bit bigger. The reason why the ancient sorting room works a lot better than this reenactment is because the environment that we see in the room is familiar. But in this picture, I just drew some lines which are not straight, so in the picture it needs to be something familiar, like a person, and in the background some actual room. Conclusion: we can manipulate the human sense of size by moving bigger objects back. The base distance of an object from the camera matters greatly, and we learn that even if the ratio of objects are proportional, we might not get the same. And we see that when objects get bigger, we need to move them slightly a bit more back. The reenactment of the ancient sorting room was not as successful, and then we could only see a slight change in the size of an object. And that's it.
Okay, the next stage is take clarifying questions by the opponent.
Could you please go to the, I think it's the fourth and fifth slide for a question. Can you explain what converge means?
Converge, they all go to the same point, the focal point. They all converge at the same point.
That's it for the question.
Okay, you have 3 minutes to prepare.
So this was the problem. So what do you think the important parts of the problem are?
The important parts are to discover which methods allow you to tell which objects were closer and which were farther.
Sorry, first the statement by the opponent. If you don't have a statement, we can go to the discussion.
So there was a part, you should announce some statements about regarding his presentation and
I think his presentation was good. He used full sentences, and on some parts it was hard. You were talking fast, so on some parts it was hard to understand.
now we can go to the. Please continue.
So I think he solved the whole problem. So the pros of theory was well explained, and it was explained as well how lenses work, and the cons are usually to use the whole sentences and didn't write down which camera you used. The experiment, so there was a lot of measurements, a lot of pictures you took, but you worked only with cubes. So what do you think maybe it could change with other geometric lines? The pros are also conclusion. We missed this one, and we didn't. So, without going for discussion, what if you use other geometric lines? Do you think it would change?
Well, I think it wouldn't matter because I just needed to see how the height of an object changed, not the, let's say, volume or surface.
Okay, and what about, let's say, a ball? It has all the round sides. Would that matter?
No, because I looked only at height of an object, not at some other.
And could you predict the length between the cubes so they seem the same?
Yeah, I was going to create a graph which would predict the sizes of other objects in certain ratios. So if I had some ratio and a certain distance from the camera, I could predict how much I would need to move away the objects so it would seem the same.
Do you know that now?
No, sir. At this this time I do not.
Now our clarifying questions from the reviewer.
I don't think we need any clarification.
What?
I don't think we need any clarification. We can go to that.
Okay. Preparation of the reviewer.
Okay, so the time is up.
Okay, so I think the presentation was good, the theory was well covered, and I think the idea to use different size cubes and then look at which distances they have to be apart to look the same size, I think that was a good idea, but I think a graph would be useful so we can see actually how independent, because it was very hard to keep track of the different distances in the presentation, and the conclusions were also good. So the points for discussion were what different geometric bodies affect measurements, and I agree with the conclusion that we do not, because we are only measuring the height, and that's the only thing that matters. And the other one was if the differences, the distance between the two objects can be predicted if we want them to look at the same height. And I also agree that that is possible, and that I think that would improve the presentation. And I also think an interesting point for discussion that could be brought up was why are the cubes that are the same ratio but different size, why do we have to move them more apart? So why are there differences?
Well, right.
Concluding the remarks by the opponent.
I think that the reporter did a good job. He explained almost everything we asked him. If he forgot anything, the reviewer had covered a lot of things which he said.
Concluding the remarks of the reporter.
Okay, so the opponent used her time a little bit better. She could ask me some more questions or ask me to clarify something, but she did not, but her questions were rightly proposed, and for the reviewer you had well thought out questions and conclusions for both of us, and you both portrayed us very well. That's it.
Clarifying questions of the jury. Anna, do you have questions?
So, do you think that 1 over 2 and 2 over 4 ratios are different?
I didn't hear you a little louder.
Ratios 1 over 2
Yes.
and 2 over 4.
Yes.
You propose them as different ratios.
I could use some ratios. So when I use the 4 to 5 ratio, we needed to move the cubes just not very much. So when I could use some ratio like 1 to 6, it would need a very big distance to make it seem the same. And by comparing the 1 to 2 and to the 4 ratios, I thought it would be the same distance, but it wasn't, which I don't know the reason for at the time.
Okay, but we are talking about ratio here.
Yes.
That means that you had dimension of cubes. What was the dimension of cubes you used when you say 1 over 2 ratio?
Okay, so 1 centimeter is cube. Let's say it was 1 centimeter high, long, and width. So, and for the 2, it's just 2 centimeters.
Okay, and since that is the ratio,
Yes.
just for further notice, 1 over 2 ratio and 2 over 4 is same. But base size of the cube
Yes.
can be different. So when you use cubes with 1 centimeter and 2 centimeter size,
Yes.
and cubes with 2 centimeter and 4 centimeter size, ratio of dimension is the same.
Yes.
So maybe just you could use different.
Maybe you should state that the ratio is 1 to 2 and state the absolute dimensions.
Okay.
That's it. Domagoj?
Let me check. Can you go please to the actually the number 3? No. Sorry, I've seen 7 or 8. 8 probably, yeah, 8 slide. Great, thank you. I see these pictures, and this is ratio 4 to 5. This means 4 and 5 centimeters.
Yes.
Okay, great. Do you think that the position of your camera affects how much you need to separate them to have a? Because as I see from here, when they are like to each other, I believe that you use a normal camera, of course, and like you filmed it from a little bit of height because the lens is a little bit above the ground, of course, because of the device. What do you think it would be if you like put it a little bit you put it in a hole or something like that? The lens would be on the like ground level, if you understand.
So I think that I would get pretty much the same results, but maybe not the same, because we will see the bottom side of the cubes more clearly, so they will be in a level with the lens.
Okay.
So they would seem more appropriate, but the top part of the cube would seem disproportional. I created it so it would be in the middle of cubes, and it would be all of the pictures are at a certain height. So they would all be the same.
Okay. Yeah, that's about me for now.
Okay, I have a few questions. Well, first one, if you knew the camera has multiple lenses in it, okay? So if you knew the lens specifications, could you have predicted in which distance you would need to put objects to appear the same?
Yes, if I have descriptions of the lens, I could create.
Okay, so which specifications do matter of a lens?
Of a lens, well, it matters. Well, it matters how big it is.
So the area does matter.
The area, yes.
Okay.
Let's say the how much it is curved. So the curvature of the
So
lens.
is that the focal length you have mentioned, or is it something
Yes,
other?
it affects on the focal length.
Okay. Okay. The next question is, if you used different cameras on the same set, you would need to move your. Would you need to move your cubes to appear the same size? If you didn't know the specification of camera and the other camera was different and placed on the same place where the first camera was. If you understood my question, sorry.
Yes. So yeah, the results would be different because obviously the lens is different, so the focal length would be different.
Okay. So you would need to adjust your distances. Okay. Is there any other way to manipulate how we perceive the object sizes? Let's say without moving the objects further away.
Without moving, yes, we could. Let's say we have one bigger and one smaller cube, and they are at a certain distance from the camera. If we manage to blur out one of them, they would seem bigger than the other one.
Okay.
And changing the background would matter.
The background pattern. You mean?
Yes.
Okay. Well, that would be.
Okay. You have question?
Later, like suggestions or something.
Okay.
So please, yes.
Okay, first go to your hypothesis, please.
I didn't hear you.
your hypothesis, if you could go to the slide with your hypothesis. So the third one really isn't the hypothesis. It's I will try to reenact. So that's maybe your goal that you should state on the second slide, maybe, or just that's. I don't want someone to think it's a hypothesis, okay, or try to change the sentence. So yeah, I thought you had some equation for determining where to put the cube, but later I found out that you didn't. And yes, I agree with others. You shouldn't put all the combinations on your slides. So you should have some methods, describe a method, how did you measure it, and then put like one slide that gives an example to us, maybe a few pictures, but the graph would be a great idea, and maybe try to derive the equation that would give you where to put your object, or at least empirically find out what would be the equation. So why did you explain how does the lenses work? How does that affect your experiment?
Okay, so you see that these are the lenses that are used in cameras. So at the focal point, all let's say light that passes is in the same point.
So what's the most important part of that can give you a photograph that violates the intuitive judgment of relative distance? So why does this happen?
Because the light that passes is not, it is curved. So when we see the object moving back and shrinking, it's not actually shrinking, but the picture in which the position is taken from, because the light reflects from it. That way it seems that it is smaller than it really is.
Okay, yeah, that's a good answer. Also, I would mention that the picture is two-dimensional, so
yes,
that's the reason why it's possible. Did you use the same camera on all pictures?
yes.
And what other parameters of the camera influence your measurement? Like if you use different optical zoom, would it change the distance you had to put your object?
If I use a different zoom, I believe it wouldn't matter much, but it may could.
Recently you told that the focal length or the curvature would influence. So yeah, you'll need to try to find that out. I have more questions.
Please.
So what were the methods that allow you to tell which objects were closer?
So you mean if we put the objects so they seem the same in the picture?
Yes.
And I try to see. So the basic thing is that they are not in the same level. Let's say I needed to move the first object up to be in the same level as the one in the background. So we can see that it isn't at the same level, but they seem smaller. So
could you measure it from the photograph?
Yes.
Okay, you need to describe it how, and maybe try to find more than one method. So maybe if you have some pattern on the picture that could help you. Because the problem states that you need to state what methods allow you to tell which objects were closer and which were farther. And it would be a great plus if you could quantitatively define it. Did you measure the size on the photograph, or
What do you mean?
so when you compared are the two objects the same size?
Yes.
Did you measure it, or you just state that it?
Yes, I measured it so they would seem the closest.
So
I actually
how
took-
did you measure it?
So I actually took more pictures after ones that equaled the size of the cubes, and they seemed.
Okay, but how did you state they were equal size on the photograph?
So I looked at pixels and how big they are. So I just compared how many pixels. is-
What program did you use?
I can't remember the name of it.
Okay, you use some kind of program. Okay.
Yeah.
Is the distance measured in? So would it affect the experiment if you placed your object at the edge of the photograph? Not so the object you're putting behind. If you put it on the edge of the photograph.
So
So the more curvature influences the photograph if you are on the edge.
well, yes, because the object isn't in the same, let's say, path as the one that's closer.
Okay. Yeah, poor presentation design.
Okay.
Too many words.
Yeah, I tried to fill
And
the-
also in the statement, first you should defend your solution. So the reviewer told something, the opponent told something, and you should then defend it first. And thank everyone for the fight. And then, if you have time, you could state something about the quality of their presentations, but that should be the last thing, and maybe even not to speak about it. Yeah. For Ana, the last thing you should mention is the quality of his presentation. So that is the most obvious thing, and you should concentrate on the problem. Also, you had the statement, but you didn't know, so a little more teamwork would be better. Yeah, yes. So those two questions you put in the first slide maybe should go to the last slide. And for the Grgur, you should use your time for clarifying questions. I know you know what to say next, that's okay, but on the international competition, your team will be preparing your presentation probably, and they'll get 2 minutes more if you just ask questions. So you could have asked, question for Ana, why do you think the model of camera will influence, or do you think it will influence, or what the opponent thinks of does the geometrical shape matters on the image. So that you should have an opinion.
I think it wouldn't.
Yeah, it probably wouldn't, but the reason is because the people will ask you for your opinion, and you should even state it in the discussion. Okay, we conclude one question, my opinion is this. We can go to the next question and so on. Domagoj, you had some question?
Yeah, I had some comments and everything, but you already mentioned them all. Actually, so
Okay.
great. I don't have to speak so much, but can you go first to your hypothesis a little bit more to the second slide, I believe, or sixth one. Okay. This first one, I could manipulate the human perception of size by moving bigger objects further away from the camera and putting small objects close. Regarding the human perception, do you believe the perception is the same with all people? Do you believe everybody has the same perception of depth on everything?
No.
How is actually perception made? Do you have any psychological or biological idea about it?
Yeah, so not all people see the same. I need to wear glasses to see better.
Okay.
So some people don't see depth same as normal people do, but in most cases this is the thing that we see. So some people have illnesses that affected the eye or the brain. So when we see something, the eye collects, let's say, the refraction of light going towards the eye, and the information of that goes towards the brain where it is processed. So a lot of things can go affecting that in the past from the eye to the brain, and the perception is not the same at all.
And when you now mentioned your glasses, like, did you take your pictures with glasses or without glasses?
I took them with glasses.
With glasses, okay. Do you think it would affect if you'd have done it without glasses?
Well, not too much because my glasses aren't that. Yeah.
Uh-huh.
Okay.
Yeah, thanks.